Okay, so our topic for this week is going to be continuation of last week. At the end of the meeting, we just really quickly went through maybe like two map and set questions, but we're going to work on some more map and set questions today, and also talk about language specific stuff a little bit more. So in the Discord channel, I've linked Java maps and sets. So I think some people in the last meeting kind of were mentioning that they didn't, it, some things weren't in their native language, in their programming language. So hopefully that'll help for the Java part, and C++ will be demonstrating, and we also have a new GitHub account with some sample solutions. So we might be linking to that instead of just posting files to sample solutions, but we'll see how that goes. But I guess we can start with, I honestly think the easiest question might be like CD. What do you think? CD actually has a pretty large input size, but otherwise it's relatively straightforward as long as if you get that there's multiple test cases, and then you also have to make sure that you're using a fast input output method, then it's straightforward otherwise. So maybe we'll start with that question, and maybe, yeah, does that sound okay?
Sure. Are we gonna go over that presentation, or we're just gonna go straight into the problem?
Yeah, I mean, not everyone uses Java, so I think we'll just do that.
Okay.
So we can read over. Okay.
Can I ask like one question?
Yeah.
So actually I'm new to this group. Like today only I joined, like my friend referred me. Can you just tell me what's really going on? And I really don't know.
Oh, okay. So should we stop recording or no? Well, can just keep on going, maybe?
Yeah, we could pause the recording for this.
Okay.
I'm sorry.
Let's see. I don't know.
I could do it.
So for this first question, I think we're just going to go through it a little bit more quickly. So to explain this problem, and this, where'd it go? This problem, this Jamboard you can find in the chat of the Zoom. So just to explain a little bit, so there's Jack and Jill each have some CDs, and I guess they live together or whatever, or maybe they can share their own CDs. So if Jack has a CD collection, Jill has a CD collection, if they have duplicate copies of CDs, then they want to sell it off. So they have at most one copy of each CD between the two of them. So Jack has a bunch of CDs, and then Jill has a bunch of CDs, and then if it's the same or something, yeah, that's probably bad representation, but kind of get the point. So what are ways to do that? You can either, let's say, have list all the ones for Jack, and then you could either sort and use like binary search, or you can use a set, but today we're talking about sets, so I think we'll be using the set today. By the way, who chose this problem? Do you want to explain? Is it Jesse?
Oh, what did you need me to explain? Like how it works? Or what it says?
Or if it's okay. So let's say you have CD 1, 2, and 3 for Jack, then and then Jill has 5, 1, and 2 or something. Then you need to be able to find the duplicate ones. So one way to do it is to save all the ones for Jack, and then for every Jill one, check if it exists in this list. And so one way to do that is to maybe sort it, and then you have 1, 2, and 3 in this sorted list, and then you can binary search 5 or something. You can binary search 1 or something, and mark it down. And either both people only have 1 copy each, so that would work. But we're using sets, so we have a set with like 1, 2, and 3, and we want to insert into this set for Jack. And then for Jill, we have a list of like 5, 1, and 2 or something for an example. And for every one, we want to do like set dot like contains or something. It's different for every language, but like set dot contains 5, then that means we get the duplicate and we want to increment the duplicate count or something like that. And then at the end, output it. And another important part about this problem is that there's multiple test cases. It's really hard to tell, but there's multiple test cases. You need to keep on going forever until you see 0, 0. So those are the 2 pitfalls. And yeah, but it's relatively straightforward. I guess I have some sample code. So I just have an infinite while loop here.
Wait, shouldn't we have people like try to solve it before we show them the solution? Right away?
This one, the other ones are way harder. And this, does that make sense, the explanation? I think otherwise it's just like, oh, wait, this is the binary search version. Oops. I think, yeah, so this would be one way to do it. But how do you want to do this? Did that explanation make sense?
Yeah.
Okay. So basically, yeah, we want to create the set for Jack and then check all the ones for Jill, or we want to create a set for Jill and then check all the Jack ones and check if it's contained within Jill's set or something. So that's what you would do. And you can either use hash set or tree set or whatever.
Does anyone need us to explain like what a set is, or is everyone good on that?
So from last week, sets are a type of, I would say, abstract data type that allows you to add to a set, remove to a set, and change or check whether something is contained in the set, and it returns true or false. So how it would work is you create the set, the specific type of set, and that would be a data structure. And for example, in C++, you might use a regular set of int, and that would be a tree set. It would be based off of a binary search tree. And you could insert into that. You can remove from that using erase. You can add using insert, and then check by doing like set.count or something. In Java, you could say tree set or something like that. So a Java example, so maybe, yeah, so this is a set example. So you have a hash set, or you can use a tree set, it doesn't really matter. And then you input in each of the CDs, and then you add to the set each CD for Jack. And then for all the CDs for Jill, you want to read in the CD and check if this set contains the Jill CD. So, and then output. And important for this is that you're using a fast input method. So I have a template for buffered reader custom scanner class, and it just has some, and it uses buffered reader and string tokenizer to basically work just like scanner. So you can use next int, next long, next double or something, kind of like you would use with a scanner, but just using buffered reader and string tokenizer. So if you have something set like this, it's really nice, and you can find that in the Discord, or you can ask. And yeah, if you use Java, if you don't use a fast input method like with buffered reader, you're not going to pass this question in particular. So you're gonna face issues like that with Java. Not really with C++ at all, but you will see that issue come up. Okay, and if you haven't already, you can go to the contest site and click on join the contest and go back to standings, and then you should be listed as a person here, and go to C, and you can submit here, things like that. So that be one way to do it. And yeah, CD, maybe try it out on your own time and can talk about, can I just talk about the other problems, or do you want to have more time to work on it? I guess this is a basic question, so let's just spend some time working on it a little bit, if that's okay. So hopefully everyone got like a general idea of sets. And so you need to insert into a set, and then once you insert into that data structure, you can check whether or not it exists within that. And there are different types of sets. So a set is just anything that can do these functions, adding, removing, and checking. And so the default set in C++, for example, is a binary search tree. So you have a tree structure, and it's a balanced binary search tree. So you can find elements within this tree structure, or it might be in a hash set. So you run the key, that value, you run it through a hash function, and it stores it somewhere. So the thing might be like an array. You might have a big array, and then you might run the key through a hash function, and then that value will be stored in a bucket at the index position in an array, but the data structure is called like a hash set, hash map, or something. So that's kind of how it works. And then in general, hash sets, hash maps are faster because they're not ordered, and it scales a little bit better over time. So that's the basics for this question. And then the other part is just going to be, are you doing the checks for the loop, and are you inputting all the values, and if you're using Java, are you using a fast input method? So these are the things that are kind of important for this question. But in general, the point of this question is just to say, can you write a set, a tree set, or a hash set? A tree set would be regular set in C++, and then hash set would be unordered set in C++. In Java, a tree set would be a tree set, and a hash set would be a hash set. So maybe more simple, but same, pretty similar syntax. So you have cd.java. So hash set of integer s is equal to new hash set or something. So a little bit different, but you're doing the exact same thing. And then you add into the set for all the values for Jack, and then check all the values for Jill. So that's a really, really basic use. Just checking for duplicate numbers is the most basic use of the set. So that's why we went over this question first. So does anyone have any questions about that? And if not, can...
Yeah, I want to add something.
Okay.
So in case you're new to set, one thing is you cannot access the element in the set using index, like arrays and vectors.
Yeah.
So be considerate on which data structure to use, because this problem we just need to like check if the element's there. So yeah, we use set. But if you need like kind of index and stuff, like use something else instead.
Yeah. really good point. So yeah, if you look at the data structures recording, we talk about ordered lists versus sorted things versus like unordered. So that kind of distinction as well. So maybe check out the data structures talk. So I think we'll move on to the next problem. Maybe like awkward party. It's probably the next step. Does that sound good? So this is going to be problem B. You can take a couple minutes to read over this, and I'll come back at 5:18 or something. Yeah, 5 minutes. You don't have to write everything, but just think about what you need, what information do you need, and this is kind of confusing actually, this problem. So maybe we'll explain it a little bit, but good. So hopefully you got enough time to look over the problem. It's pretty confusing, but so you have, let's look at the first example. We have 4 people, and the languages they speak are going to be 1, 2, 3, and 1. And for every person, their awkwardness is going to be how far away is the person that they can talk with. So in this case, it'll be 1, 2, 3. So this is awkwardness 3. N can't talk to anyone. 2 can't talk to anyone. So their awkwardness is like N, I guess, which is 4 in this case. 3 can't talk to anyone. So it's like N. And 1, it's the same. So they're 3 spaces away. And then the minimum awkwardness for everyone is going to be equal to 3 in this case. And if no one can talk to each other, then it's awkwardness N, something along those lines. So hopefully that makes sense. That's the premise of this question. And so the next part is, how do you find the person who speaks the same language? So there are a couple ways to do this. Maybe anyone? So there are a couple ways to do this. So for every language, you want to find someone else with the same language, right? So and you need to find the index. So you need to find the index of same language. So what's one way to do this? Maybe you could, one way to do it would be to split into groups of like 1, 2, and 3 language groups, and then say like the index value for 1 is going to be 0. And then the other guy that's 1 is going to be index 1, 2, 3. So index, so you have groups 1, 2, and 3, and then you can keep on adding these index values. And so that might be index 1, this might be index 2 or something. And if you find something else, you can kind of subtract this, and then here the awkwardness is 3, right? So that's one way to do it. So what would this look like in code? Then you'd have a map of integer and maybe like a vector of int or something. Int. And then you could go through that. For every value in the map, you could go through the vector, and which is like an array, and then say, so in this previous example, we had 0 and 3. So you could say for every value, index 0, index 3, and then if you can create a pair here, and then let's say there's like 5 or something, then you can keep on checking the next value, checking the next value, and find this value. And then at the end, like awkwardness is equal to n, and then whenever you do this check, you can do minimum of current awkwardness and the answer or something like that. But you might kind of notice that, do you really need like to store all the index values here? And so let's say we have an example like we have 1, 2, 3, 1, 1, 4, 1 or something. So do we really need to store all the people in one, or do you just need to store that one person before? And that's going to be, as long as you know that last person in this single row of awkward people that speaks the same language, then you're going to be able to find that. So let's say the index value is 0, 1, 2, 3, 4, 5, 6. So as long as you know the previous index value of the person who last spoke the same language, then you only need to store one value at a time. So you don't need the entire, you don't need an entire a vector stored with the integer, even though you can do that and it might pass. You can store one at a time. And so what you do is insert into the map the index value 0. So for 1, you'd store 0, and then for 2, you'd store 1, and then for 3, you'd store 2. This is the last index value, and then we get to 3. So we have 0 here already, so we can update this to become 3, and then awkwardness minimum is equal to 3 instead of like I guess there's 7 total values. So instead of 7, it's 3 now, something like that. So as long as, and then 4, so 4, you can cross this out, and then awkwardness becomes 1, and then skip. So 4, we add another bucket for 4, and then go to 6, cross this out, 6, and then this was the awkwardness value of 2, but 2 is greater than 1, so minimum awkwardness is going to be 1 for this example. Does that make any sense? No. It doesn't make sense.
It makes sense. Makes sense.
Okay. Okay. Yeah. So basically you want to set up a map where you store, you want a map that has int, you want to search using that group, that language number. And then what you store in that location, you want to store the index of that last person. Yeah, the Kattis problems are written really in a confusing manner. So maybe you can take another 5 minutes and see if you can come up with a little bit of code. Yeah, in that time. So how to set it up would be, so let's say you're using, so you want a map of int. And so in Java, that would be integer or something. Yeah, and any type of map should do. So some kind of, yeah, some kind of map, maybe Python would be dictionary. So set up a map and then insert in the index values for each group. So, and if that value exists already, then you want to update it and take the minimum awkwardness. So maybe take 5 more minutes. I'm gonna pause the recording. They're written by Russians, so questions are confusing. Yeah, maybe. Who knows? Where's this from? Bergen? Bergen is, I don't remember, somewhere in Europe. Yeah. So hopefully you got a little bit of time to try the problem out, right? A little bit of code. Yeah, this is a pretty simplified form. Yeah, I solved it before, so it's a little bit cleaner, but one thing you can do is notice that yeah, you only have to keep track of the previous index, and then this minimum awkwardness is going to be that difference between indices, and find that minimum. The current awkwardness is going to be the current index minus the value stored. So, and compare that to the default value of n. So, and in every case, you have to set the language for that language bucket you set to the current index. You do that in every case, so you can just have one line here and do conditional if it already exists. So very short code if you simplify it. So hopefully that makes some sense. It seems like a couple of people have tried out problem A, which it's honestly not that hard, but it's a lot. There's 5 subproblems here, so just really be careful with subproblems. And if you're using Java, you have to do a fast input method and output method. So there's actually a presentation, Java map and site you can find on the Discord channel, and then it goes over this problem. So you can check out this. And yeah, maybe try out these problems. It's been a full hour, so probably going to be wrapping up. And then D, so basic programming 2, you should be able to solve it with the information from today. Yeah, you have to use sets and maybe a map or something. Adding words is really annoying. You do use maps, but it's also really annoying. So yeah, if you don't get adding words, don't worry about it too much. A really good way to solve this problem is to use something called like string stream if you're using C++, or you can use string tokenizer. So input line by line, and then use a tokenizer of some kind to get one token at a time. And then you can read in one section at a time. You read in the entire line, and then you can pick up each token. So you might write like a short hint thing on that. But if you don't do that, it's going to be really, really annoying. And then the last question is greeting card. Greeting card, yeah, this is pretty tricky as well. Yeah, this is pretty tricky. One thing you have to do is, yeah, but we'll release some hints on that as well. So is there anything anyone else wants to add? Any questions? Yeah, so we'll wrap up for here, and you can keep on doing this for the entire week. So you have some time, and we'll post some hints, some ways to work on these problems. So what kind of things you should try in some sample code as well. So it's going to be it for today, I think.